All right, in this section of the notes, we're going to talk a little bit about tension. I'm going to give you guys two scenarios. Okay, the first scenario for our tension is if we have let's say a speaker that is hanging from the ceiling by a chain. So here's my speaker, and it is hanging from the ceiling by one chain. So just one chain is connecting it. So off to the side, I'm going to draw my free body diagram. So I have my mass, that's my speaker. It is hanging. It does have gravity, so we are going to draw in, or it does have a weight force, so we're going to go ahead and put the weight force in. What is counteracting that weight force, keeping the speaker from falling, is your tension force. And we just got done looking at the video of if my object's not moving, my net force is 0. So in this case, because my object is not moving, I know that the magnitude of tension is equal to the magnitude of weight. Now let's add some numbers in. Our speaker is, let's say our speaker is 30 kilograms. All right, so what is the weight? Well, the weight is equal to the mass times negative 9.8 meters per second squared, because that's the acceleration due to gravity. We learned that first semester. So we have 30 times negative 9.8. So we get a weight force of negative 294 newtons. So what does tension equal in this case? Well, tension is going to be equal to the magnitude of weight. And weight being negative 294 means that tension is equal to a positive 294 newtons. So that's how I would calculate tension. So that's our first scenario. Our second scenario is a little bit more complicated. And this scenario is when I have my same speaker, only this time the speaker is held up by two chains. So we've got a speaker that was originally hung up by one chain, but we find that it was just too much pressure on the chain, so we decide to take this speaker and hinge it to two chains. Think of like a jumbotron and the speakers that get hung up around that, right? And so now we have two chains the exact same length, and they're being hung, and they're holding up the speaker with an angle to the ceiling of 40 degrees. And both of them are exactly the same angle. So we have two tensions. We're going to label them tension 1 and tension 2. But the fact is that the speaker still isn't moving. And we know that when an object isn't moving, that the forces are canceling out. Well, the only way forces can cancel out is if they are opposite each other. So meaning if I have a force that's going down, then a force that's going up will cancel it out, not a force that's going at an angle. All right? So we have our free body diagram we're going to draw. To represent this picture, so we have a free body diagram. Here's our free body diagram. That's our speaker. And we have a weight on the speaker. Now the speaker is still 30 kilograms. same speaker. So our weight is actually still the same. So I'm going to go ahead and throw that number in here. It was negative 294 newtons. Now it's not moving, which means there's an upward force that is exactly equal to that force. Or their magnitudes are equal. And we're going to call this the total tension. And the total tension is equal to a positive 294. I'm going to give myself a little bit more space, so I'm going to move this right down here and analyze it here. Okay, so here's our free body diagram. I noticed I didn't draw in those forces because I don't need to. I have them all right there. They're both pulling up and out, but they're canceling out this weight force. So here would be your free body diagram. Now you could, instead of drawing this, you could draw these guys in. But this illustrates the net force, so the object not moving. All right, so let's go back to our picture, and I'm going to actually draw this force in, and that would go right here. So this would be my tension total. So that's what it would look like. And then your weight force would be in the other direction. But how do I calculate the tension of on each chain? Well, I'm going to go ahead and draw a separate picture where I have just my tensions. And this tension total is actually a combination of the two. So if I were to take the two tensions and put them together, I would have tension 1, tension 2 here, and then I'm going to bring my tension 1 over, and I'm going to bring it over here. Here's my tension 2, or tension 1, and this angle here is still 40 degrees. And this is going to help me calculate each individual tension. Why? Because I just drew a right triangle in. Okay, now this whole side right here is tension 1 plus tension 2. But tension 1 and tension 2 are exactly equal. They're equal because their angles and their length are the same. I will not give you a scenario where they're different. So they're equal. So what we can do is we can call this side 2 times tension 1. Or 2 times tension 2. Because they are equal, I can just double one of them. So now we have a triangle where my hypotenuse is equal to 2 times tension 1. Or tension 1 plus tension 2. Same thing. All right, if I put a spotlight on my angle that I'm given, it shines on the opposite side, so I know that the opposite side is your total tension, which I know is equal to 294 newtons. It's coming, guys. SOHCAHTOA, here it is. SOHCAHTOA. or TOA. Which one am I going to use? Well, take a look at what you have. You have the hypotenuse and the opposite. So we're going to use sine. So the sine of 40 degrees, again, what are we solving for? We're solving for tension. We want to know what these tensions are. But in order to find them, I need to know what this whole side is equal to. So the sine of 40 degrees is equal to the opposite over the hypotenuse. So sine of 40 is equal to 294 divided by, we'll call it 2 tension. Tension 1. Again, what's your goal? Goal is to solve for one of the tensions. They're both the same, so if I can solve for one, I'm good to go. All right, switch the denominator with the numerator, or with the sign, so flip-flop those so you can solve it. And you get 2 of the tensions, 2 tension 1, is equal to 294 divided by the sine of 40 degrees. And if I take my calculator and I type this in, I get 2 of the tensions are equal to 580, no. I take my highly sophisticated device and I'm going to type it in, and I get 457.3, approximately 457.3 newtons. I'm going to divide both sides by 2, and I get approximately 228.69 newtons. So one of your tensions is 228.69 and the other one is also 228.69.